This is Clever Hans, a horse who became a real celebrity in Germany in the early 20th century. He seemed to do it all: add, subtract, multiply, divide, recognize colors, identify coins, tell the exact time and even point out dates on a calendar. His way of answering was simple. He would tap his hoof the right number of times, and it looked like he genuinely understood math and human language. The story amazed people so much that a whole commission was assembled to test him. And here's the wild part. They found no fraud. Even when his owner wasn't around, Hans answered strangers' questions correctly about 90% of the time. But eventually, the secret came out. It turned out Hans could only succeed if he saw the person asking the question, and only if that person used the correct answer. So how did it work? After each tap, Hans carefully watched the human's reactions. When he reached the right number, the questioner would give off tiny signals: a shift in posture, a glance, a slight facial change. We wouldn't even notice them. But Hans did, and he stopped right on cue. So, no superintelligence here. The horse had just one extraordinary gift: sensing microsignals. That's how we discovered that people unknowingly reveal information through facial expressions or gestures. Today, this is called the Clever Hans effect. In psychology, it makes sense, because we constantly influence each other. A dog picks up on its owner's mood without words. Or a child learns faster when a parent encourages them with a smile. Or even a stranger can feel whether we are nervous or confident. But in physics, the question goes way deeper. People have long debated. If a tree falls in a forest and nobody is around, does it make a sound? Does the moon exist when nobody is looking at it? On the one hand, of course, the tree still falls, and the moon isn't going anywhere. But on the other, what if our presence really does change something? For centuries, this was just a philosophy, but then came quantum physics, and it explained a lot, yet at the same time gave the observer almost magical powers. And it turned out that simply being an observer could change the state of particles, or affect the outcome of experiments, and even break the normal laws of nature. And it's a paradox. The observer seems to do nothing, yet everything changes. And to show this, Erwin Schrödinger came up with his famous thought experiment. Imagine a box with a cat inside. Alongside it is a device tied to a uranium atom. If the atom decays, the mechanism releases poison and the cat dies. The decay is purely random, so until you open the box, the cat is both alive and dead at the same time. Sounds crazy, but that's exactly how particles behave at the quantum level. They can be in two places at once, spin clockwise and counterclockwise at the same time, move along multiple paths simultaneously. This is called a superposition, but here's the kicker: you can't actually see it. The moment we observe the particle, superposition collapses, and it chooses just one state. Open the box, the cat is either alive or dead. Only one outcome remains. That's the observer effect. By simply being present, we shape the fate of particles. You might think this is just about measurement, like to know where an electron is, you have to hit it with a photon, and that changes it. But the paradox is bigger. Particles behave differently even when we don't touch them directly. The double slit experiment. The most famous proof is the double slit experiment. Take a screen with two slits and fire electrons at it. If no one is watching, they form an interference pattern on the wall, waves overlapping, like ripples on water. But the moment you put a detector near one slit, the pattern vanishes. The electrons behave just like simple particles. And here's the strange part. Even electrons that weren't directly observed change their behavior, as if they know they're being watched. Does that mean observation itself changes reality? Because it almost looks like nature, once it realizes it's under surveillance, hides its secrets. Our intuition says that the universe shouldn't work this way, because it feels messy. Observer effect and quantum reality. Truth or myth? Let's set the ground rules. For us, observation means learning something new about an object. It's a color, mass, position or energy. Otherwise, why observe it at all? In other words, observation is always measurement. And the observer effect shows up not only in quantum physics, but also in everyday life. For example, measuring tire pressure. You can't disconnect the gauge without letting out a little air. Measuring current in a circuit. The ammeter, even with low resistance, still slightly distorts the result. Taking a contact temperature reading. If the thermometer is colder than the object, it draws energy, and the reading is already different. These are all small observer effects. Nothing mystical, just you can't make an omelette without breaking some eggs. But at the quantum level, things get much stranger. So what's really happening? The explanation comes down with three key ideas. 1. The wave function. It's an equation that describes all possible states of a particle. Our observation collapses it down to just one. Where it's going, where it's been, what states it could take. Everything's in there, including superposition. But once we observe, the wave function collapses, leaving only a single random outcome. Physicists call this the collapse of the wave function. And this exact moment raises the biggest questions. 2. Quantum entanglement. When two particles become linked, the state of one instantly reflects the state of the other. Think of a pair of gloves. If you find the right one, you immediately know that the left is in the box. But particles go further, like twins that always feel each other. If one spins clockwise, the other spins counterclockwise. If one flies right, the other flies left. And it works even if they are separated by thousands of miles. Take Schrödinger's cat again. At first, only the atom is in superposition. But then the atom gets entangled with the device with the poison vial, the vial with the cat. Soon the entire system is described by two simultaneous scenarios. When we open the box, we see just one, cat alive or cat dead. But for a while, both really coexist. And here's the twist. The moment we open the box, we ourselves get entangled with the system, meaning that in some sense, we too split into versions. One sees the cat alive, another sees it dead. Sounds like a science fiction, but this idea is the many worlds interpretation of quantum mechanics, and more scientists think reality actually works this way. Each version continues forward, in its own parallel reality. Like say files in a video game. In one world you overslept your work, in another you made it on time. In one you met the love of your life, in another you walked right past them. Wild, right? But serious physicists actually debate this. 3. Decoherence. This is what stops us from seeing those parallel worlds. Decoherence happens when particles interact too much with their surroundings. And superposition falls apart, like playing a pure guitar chord, then adding so much noise and distortion that the melody vanishes. Same with particles. The more they interact with the environment, the faster superposition breaks down. So it's not magic. It's not that the observer has superpowers. It's just the natural chaos of the universe doing its thing. Every time we measure something, the universe seems to branch into several versions. We only live in one, but the others exist too, experienced by our other versions. Mind-blowing? Absolutely. But also inspiring, because it means that somewhere out there you might already have everything you ever dreamed of, and somewhere else you made completely different choices. Either way, they're all part of one vast layered universe. And here's the takeaway. There are no magic here. The observer effect isn't about superpowers. It's about how reality actually works. If you watched until this moment, respect. I'll be posting many more videos about science, technology and mysteries of the universe. So don't forget to subscribe. I know some of the ideas, quantum superposition, parallel worlds or observer effect, can be hard to wrap your head around. But it's totally fine. So tell me in the comments, would you like me to make a deeper video about observer effect? Or maybe about many worlds interpretation? Or just share what you think. Does our observation really change reality?